Okay. It's called tangents, velocities, other rates of change. Kind of a bad title because we're not going to do much application with this. Eventually, we're going to do a lot of application with it. But the piece we're going to show you today, we're going to use this kind of over and over again. Okay, it's going to be in a different form, but it's going to be really good stuff. We're going to take everything we've learned so far in calculus and put it into one sample right here. You want to be able to understand this graph, and you've seen something very similar to it before. Let's go ahead and give it a shot. I've got a curve, and I would like to find the slope of this tangent line. I would like to find the slope at point A. Why is this difficult? Only 1 point. Let's give this a y value. If this is A, what would we call that?
B.
Close? F of?
A.
A. Good job. There we go. Good job. It's difficult to find the slope at 1 point, so instead we create 2 points. We'll call the other point over here x. What would we call the y value? F of x. And instead of a tangent line, that will create a secant line. The slope of the secant line is approximately the slope of the tangent line. They're not the same, but they are approximate. Would you agree? Let's find the slope of the secant line. The way we find slope of a line is we do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Good with that? I would like the green line to be a better approximation for the slope of the blue line. What could I do to make the slope of the green line a better approximation for the slope of the blue line? What could I do? What could I do with x? Where could I bring it?
Closer to A.
Closer to A. How do we bring something closer to something else?
Bring it closer.
We slap on a limit. That's how we bring something closer to something else. We say limit as x approaches A. And that is definition number 1 for slope of a tangent line, for a derivative actually, that piece right there. And what's interesting about that is in order for this to work out, we have to be very confident about limits, which we've kind of beaten limits to death, haven't we?
Yeah.
Like we've talked about the epsilons and deltas, and furthermore, we have to have a function that is continuous. We've talked about continuity, haven't we? And so we have those points in place. Now we can do the calculus thing we want to do, which is that. So let's carry out the first example. It says find an equation of a line that is tangent to the given function at the given point using definition number 1. So this is my function, this is my coordinate, my x value and my y value. And so we have the limit as x approaches, anybody know what x value I'm approaching?
1.
1, right there. Of the function x squared minus 3 minus
2.
negative 2 divided by x minus 1. So I have the function minus the y value divided by x minus the x value. And notice that we get the limit as x goes to 1 of, this becomes x squared minus 1 in the top and it becomes x minus 1 in the bottom. And so it is the case that every time you are trying to find the slope of a line tangent, you will come up with this type of a situation, such that when you plug 1 into the top, you get 0. And when you plug 1 into the bottom, you get 0. And it will always be the case that it will be what we call a removable discontinuity, that we can take x minus 1 and factor it to, or x squared minus 1 factor to x plus 1 times x minus 1, and notice the bottom divides off. And therefore, we plug in 1 and we get the slope is then equal to 2. It says find the equation of the line tangent. I have the slope is equal to 2. What is the point that it went through? 1, negative 2. So I can go ahead and use y minus y1, or y plus 2 is equal to 2 times x minus 1. We can now write our equation for our line. Y plus 2 is equal to 2x minus 2. Subtract that 2, y is equal to 2x minus 4. Take out your graphing calculator. And so in my y sub 1, I'm going to put the actual function in, which was x squared. What was it? X squared minus 3. And then for the y sub 2, I'm going to type in the equation for the line tangent, which was 2x minus 4. And I press graph. And when I do, the question is, do those look like they are tangent to each other? Absolutely. So I know I've done it correctly. What do you think?
Can you go back to y equals?
Yeah. This will be the final thing that you'll need to do for your test. What day is your test?
Friday.
Would you guys like a study guide today?
Yeah.
I have that ready to go. You good, Gilly? Okay, we head back to our notes. Let me see really quick so I can navigate to see what we want to do. I don't want to do letter B. I'd like to flip to the back side here, okay? I'd like you to try letter A on the back side on your own. Go ahead, try A on your own.
Minus 1. Why did you say that? Stop. 3 0. 3 minus 1.
Here, minus 1.
I know. Is Brody still 3?
So A would be yes, right? Maybe not.
A is going to be your X out.
So that is like, you have nothing to do with the definition part?
Nope. Yeah, don't even use definition 2. We're using definition 1. I'm not going to show you definition 2 until later on. So the thing we just did, f of x minus f of a over x minus a, limit as x goes to a. Good luck today.
Thanks.
And negative 2x plus 4? Hayden?
I'm stuck on the factoring part after that.
So if I've got 1 minus x squared, it does not factor to x minus 1 times x
Right,
plus
you
1.
take out the negative.
It's got to be 1 minus x times 1 plus x over x minus 1.
Yep.
Those are not the same, so I have to factor out a negative.
Yep.
Now I plug in 1, 1 plus 1 is 2, make it negative, negative 2.
Oh, okay.
See it now?
Yep.
Okay. Good. So, you know how to do it for basic polynomials? Let's try a little bit different polynomial. We really have 4 types of situations we're doing. Right now you saw the quadratic. Let's see the cubic. I have the limit as x goes to what? Negative 1 of x cubed plus x, then what? Plus 2 divided by x plus 1. Turns out that x cubed plus x plus 2, it does factor, but I don't see how it factors. And so another way in which we could go about this is a very easy process called, who's got it? Synthetic division. Watch this work. I put the negative 1 right here because that is the 0 for the denominator. And what do I put up top?
1, 0, 1, 2.
Good. Make quick work of this. We drop the 1, we multiply. We add, we multiply. We add, multiply, we add. And so what that tells us is the top factors to x plus 1 because of the negative 1 right here. And then it will be x squared minus x plus 2. Now we can see that the x plus 1 divides off quite easily. We plug in the negative 1. Negative 1 squared is 1 plus 1 plus 2. I've got 4 as my slope. Can I trust everybody at this point that you would be able to write your equation for the line tangent? Okay, so let's not do that so we can give you time to work and get through the other two. We good with that? Okay. This one, talk to the person next to you. What does this graph look like? Go ahead. What does a graph look like?
At
2 over.
2, 0. Yeah. 2, 0.
So,
Yeah.
for me, and I feel like this is to my benefit, these are the same things that I'm trying to tell my kids. It's just helping Temley with her geometry yesterday. She was finding midpoint of segments and
I get a pass.
trying to help her with that. But in this situation right here, I would encourage you to think about the graph ahead of time. Does everybody agree that this slope should be positive?
Yes.
And not only should be a positive, but it's probably less than 1. It looks like a small positive number. And sometimes your knowledge of the graph can help you kind of get a feel of whether or not you're doing the problem correctly. So let's go ahead and work this through. Fortunately, you've been given a really good way to figure this out ahead of time. We have the limit as x goes to what? 6 of the root of x minus 2 minus 2 over x minus 6. Shoot, I don't know what to do, but fortunately you do. What do I do?
Multiply
By the
conjugate.
conjugate.
I was on the right track.
Please keep in mind you are going to do this again in a future unit, so please pay attention to this algebra. We're going to do more things that are algebraic related in this class, and so that's in your comfort zone, but you are probably more likely to make some algebraic mistakes. So when I multiply these out, remember that when you're multiplying conjugates, like a minus b times a plus b, you get just a squared minus b squared. The middles go away, you square the front, you square the back. So I get x minus 2, and then what?
-4.
minus 4 over the denominator stays rather large. So you have this x minus 6, and then you have this quantity, the root of x minus 2 plus 2. Please make sure that you write these as two separate quantities. What do you end up with in the numerator? X minus 6, which will divide with the x minus 6. So as Anna says, it leaves you with just 1. The limit as x goes to 6 of 1 over the root of x minus 2 plus 2. Often people ask, do I have to continue to write down limit every time? I would encourage you to do so because it reminds me I still need to plug in 6. I haven't done it yet. Now that I plug in 6, 6 minus 2 is 4, square root is 2, plus 2 is 4, I get 1/4. Let's go back to my original thought. Does 1/4 match with what I predicted about the slope of this type of function? We said it would be positive and it would be less than 1. We use that to our ability. Okay? So these are the classic examples. A quadratic, check mark, right? A cubic or a fourth degree or something like that, you can always use synthetic division if you need to. With a radical, you can multiply by your conjugate. Then finally, in this situation, we will have a complex fraction. And those are the situations that you should be ready for to see on the test. We are not doing trig. We're not doing logarithmic. We're not doing exponential. Those are a much different approach. So let's see how this goes here. The limit as x goes to 3 of 1 over x minus 1 minus 1/2 over x minus 3. We see the complex fraction in front of us. What do we need to do?
Same denominator.
Common denominators, I multiply the top and bottom by an x minus 1 over here. And the top and the bottom, the other side by 2. Your 2 mistakes that you make on the test, your 3 mistakes that you make on the test, you fail to distribute the subtraction sign through. Notice I get a 2. And then I get a minus x and I get a plus 1. Okay? Second mistake is that you don't treat this denominator properly. It is just 2 times x minus 1. I always leave it in factored form. And finally, you forget to write the whole denominator after that. This is all over x minus 3 over 1. So I have the limit as x goes to 3 of, what do you have in the top? Negative x plus 3, or 3 minus x, either way you want to write it, over 2 times x minus 1. I'm not going to divide by x minus 3 over 1, rather I will multiply by the reciprocal. Are negative x plus 3 and x minus 3 the same things? No, but if you factor out negative 1, then are they the same things? So I will go ahead and factor out the negative and then reduce them. So we have the limit as x goes to 3 of negative 1 over 2 times x minus 1. At this point, I'm able to plug in the 3. 3 minus 1 is 2 times 2 is 4. I get a negative 1/4. Now, I would not be satisfied at this point. If it were me, I would write the equation for the line, and I would graph it to see if it was tangent at that spot. And without a doubt, ahead of time, I would have thought about 1 over x minus 1. Everybody agree that the graph is a reciprocal function that is undefined at 1. But we are wondering about the graph at an x value of 3. And so as you look at this shape, you know it goes like that. And for an x value of 3, Does that look like the slope could be approximately negative 1/4? Without a doubt. So again, ways in which you can check your answer and verify. So the last thing you'll be asked to do for this test is to be able to use this property using this language. Again, as x moves closer to a, how do we just do that? Easy, we slap on a limit. That's how it works. And then we're able to go about that process. All right, you guys are ready to do your last assignment. There are 8 problems on it. You do not need to do that. Tell the person next to you, where are you at in your homework right now? How caught up are you?
Wait, here.
You did the hand? Minus one.
No.
We're all like, no.
I have that. Piecewise functions? Yeah. It's in the,
Oh, you say I was about 2/3.
You're just taking something out.
That means us.
We see Laney later on today,
With the active drive.
so you're gonna not see.
I do.
Oh.
You wanna give her one?
Yeah.
Thank you. So, this test should go very well. This is, generally speaking, the highest performing test of the year. So, how do we make sure it goes well? Well, number one, I chose on Monday that instead of covering this lesson, we did a review activity together. And so I know that some of those answers you knew and some of those answers you did not know, but the hope is that after we did that, it will kind of bring some of this to the forefront of your brain as you go over it. Get my point?
Yeah.
Please look at problem number 1, where it says identify 3 requirements necessary. Make sure you know number 1. Okay? Without a doubt, you have to know the 3 requirements for continuity. We did that yesterday in our practice. We should be able to do it now. I'm not worried about 2 and 3. I think you're going to do fine there. As you flip it over to 4, A, B, C, and D, notice that you do have a couple piecewise functions and continuity there. Make sure you know how to do your piecewise functions. Problems 6 and 7 are identical to what we were doing today in class. 6 and 7 identical to what we were doing today in class. It was 8 and 9, and I switched it last night just so I could have that moment today for that.
I held it.
I held it too.
Please look at problem 8. State the precise definition of the limit. Do you know it?
No.
Let there be a function
Define
defined on an open interval, but maybe not at point A. Then the limit as x approaches A of f of x equals L if for every epsilon greater than 0, there is a delta greater than 0 that satisfies the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus A is less than delta. Andrew did not participate.
I might just take the point off.
You'd be the first one to say.
Yep, this has gone very well the past few years. Number 8, you need to know the precise definition of the limit, because when you get problems like 9, 10, 11, you're going to have to use those, because I'm not writing it down on the test for you. Okay? So, intermediate value through on the back, should be good to go. Make sure you know those definitions. You guys are going to do great. You got some time to ask questions? A little bit of time.